Hello, everyone, and welcome to CSC University's second Spring Tech Talk. Tonight we will be hearing from two of our own CSC experts on big data. I'm Amanda Wolf, part of the University Relations team, and I'm really excited to have you all here tonight. I would now like to introduce you to Nicole Tomlin, Senior Manager of Talent Acquisition for CSC.
Hi, everyone. It's Nicole. Thanks for joining us this evening or this afternoon for some of you guys on the West Coast. I am actually going to be monitoring our Twitter account, so get out there, shoot some questions for Hank and Joe, and we'll stop about halfway through. So also remember when you tweet to use the hashtag CSC Hangout, and that's with no S. All right, Amanda, back to you.
All right. Make sure you stay active on Twitter. We're really excited to hear your questions, and I'm sure our speakers are as well. So now I would like to introduce you to our two speakers, Hank Tseu and Joe Percival. Hank is the Director and General Manager of CSC's 426 branch division. 426 develops big data and mobility software for CSC's North American public sector. Hank joined CSC through its acquisition of 426 Solutions in 2012. Previous to 426, Hank served in management and engineering roles at the Boeing Company and Motorola. Hank has over 15 years of experience applying leading-edge technology to mission-critical environments in the aerospace and defense industry. Hank holds engineering degrees from the University of Michigan and the University of Maryland, and an MBA from Georgetown University. Now to introduce Joe, Joe works as a full-stack developer at 426 on the EasyBake platform. He started as an intern for 426 while attending the University of Maryland. He graduated with a degree in computer engineering in 2014. Joe works daily with many different cutting-edge technologies in every layer of the EasyBake platform and more. With that, I will hand the presentation over to Hank and Joe.
Thanks, Amanda. As you mentioned, 426 was a small business focused on mission-critical web applications for the federal government and big data. And post-acquisition, we're now responsible for developing software solutions for both big data and mobility across the entire federal, state, and local government sectors. We're interested in this topic. If you don't mind putting the slideshow up.
Sure. Give me just 1 second. All right. All right, it is all yours.
We're interested in the subject big data databases because we hire engineers.
Amanda, it went back to you.
Oh, sorry about that. I don't know what happened.
We frequently look for engineers with a lot of fundamental software development expertise and not always necessarily big data specific technologies. However, what we find generally is a lot of our talent may not be as acclimated to practical database expertise as we would hope. So, we're hoping to pass along some tips here for your next job interview to not only land your job, but also the choice assignment that you're looking for. So, next slide, please. So jumping into this, as we all know, big data has been a real hot topic for the last couple of years, and commonly we see these hockey stick type diagrams where you have this tremendous vertical growth in, you name it, whether it's interest in big data or the data being handled or the data being available, so forth and so forth. What we all know is that big data is becoming a more and more interesting and more relevant topic on a daily basis, and it's going to continue to go that way for quite a while. Now, from our perspective, it's not just volume. So a lot of our customers have terabytes or petabytes of data that need to be managed. But if you look at it, big data is not just volume. There's other V's involved as well. The big one that we've run into is variety. So a lot of times when you're looking at problem sets where you're looking at multiple data types, that's really where big data solutions really come into play. Next slide, please. So if you look across the various industries, different industries are looking at different ways to capitalize on big data technology and exploit kind of the technology to answer the questions that they're really looking for. So financial services, transportation, healthcare is a big one. It's much more beyond what Google and LinkedIn are doing as far as social networking. We're finding that there are more and more applications being discovered, and that we're able to reuse a lot of the solutions that we're discovering and finding for various customers. Next slide, please. So at the top end, in order for big data to be important and valuable to people, you have to be able to translate big data into knowledge and insight. So we just put on the slide an example of a dashboard transforming data into visualizations and graphics that mean something for the user. Can you go to the next slide, please? If you look at it, that's really just the tip of the iceberg. So unfortunately, not just one part of this equation is going to solve your problem. You really need the whole thing. So if you look at the analytic and the visualization, it's kind of the tip of the iceberg. And then underneath of it, there's a lot of database interaction, management of data, ETL, ingest, security, and so on and so forth, and a lot of other components that really drive your big data solution. At the very lowest level, you even have your platform and your infrastructure that drives how you're able to address your big data problems. So at this point, let's pause for some questions. Nicole?
I have to get off of mute. I don't have any questions right now, so we can keep moving.
All right.
Oops. Go back. Sorry about that.
All right. So what we're trying to do today is translate this into some real-world problems. So we've distilled the types of data that you might come across for real applications into a couple of categories. Now, these categories are by no means comprehensive, but it's a good start just to kind of demonstrate where it's not only a volume problem that makes big data challenging and interesting, it's also variety, right? So I'm using a financial example here. We're looking at potentially structured data. So this is what people most commonly use looking at traditional SQL and relational databases. So this manifests in rows and tables, and when you're looking at flat files, potentially CSV files, comma delimited or otherwise. A good example of what might end up in this format, historical stock prices. So for example, ticker, couple of traits or metrics describing that ticker, and then prices for that stock over closing prices over the last few months or years or so forth and so forth. Second thing we want to talk about is unstructured data. So this is commonly takes a format of items like free text forms. So a news article is a good example. Word documents, PDF. So in the context of finance, if you look at a Google Finance news article, you're looking at prose that's describing an event or activity, and in it you might have entities like a company or a person. And then you might have dates, you might have places, and all these interesting things. So with unstructured data, you have to have some kind of analytic or some kind of processor that extracts these entities and then puts them in another format for you to combine with something else. Format of items like free text forms. So the news article is a good example. Word documents, PDF. Hey, Amanda, we're getting a little bit of feedback here.
Is that better?
That's much better.
Okay.
Can you go back a slide or two?
Sure. There you go.
Perfect. Thank you. So what's important is if you look at structured data and unstructured data, so a good example of why this is important is if you're looking at an application, you might be interested in monitoring the stock price for a particular ticker, but then you also want to be able to identify any exciting news or any impactful news that might be late breaking. So you want to be able to scan a unstructured document and pull out news and decide whether that's a positive impact or a negative impact, or you might want to pull dates. Really, the applications are endless. The third category, just for example, is semi-structured. So it's kind of a mixture of structured and unstructured. And really what you're looking at is an unstructured document where there are perhaps some unofficial fields. And so an SEC filing, for example, is a good example. So if you've ever looked at an SEC filing, you'll note that there are some standard things that are common across all these filings. But at the same time, there's still quite a bit of unstructured text. So being able to process both unstructured and structured data, and unstructured and structured data at the same time is actually really important. Now, the last example I'm going to give is graph data. So the best example I can think of that everyone relates to is LinkedIn. So who's connected to who, kind of the Kevin Bacon game. It's nice to know, what the relationships are between two people or three people, or how does one person know another person, or if you kind of expand that, it doesn't have to be people, it could be any type of entity. So it could be who works for a company, who works for someone else, or someone who might actually be an officer for another company. So if you're looking at finances, it's actually very important and interesting to kind of see, who's doing what and what their relationship is to someone else who might have a stake or another impact that could affect another company. So when you look at the problem statement, these are the types of data that you want to work with. Now, in order to solve the problem, you have to take a holistic look at it. Now, traditionally, when you look at big data, I think the first thing that comes to people's minds is Hadoop. Hadoop is going to solve this, Hadoop is going to solve that. And the reality of it is Hadoop is a great technology, and it shows up more often than not. But because of the diverse nature of the data underneath, really, if you take a more holistic look at the problem, it might make more sense to introduce different technologies that are optimized for the different data types that you want to handle.
So that kind of leads into the next part of it, which is the databases that you're going to store your data in. A couple of the databases we're going to talk about today is Redis, Elasticsearch, and Titan. Redis is an example of the structured data, Elasticsearch is semi-structured, and Titan is graph data. I'm backside already. All right, so Redis is a key value store where you store very specific data types. They're anything from an integer to a string to a list to a set. Its key feature is that it is very fast. It accomplishes this by storing things mainly in memory, but then also persists it to disk. So since it has those specific data types, it's a structured data. Its intended use would be for something that's changing very rapidly, but it's relatively small. An example of this would be real-time stock prices, real-time analytics, leaderboards, or real-time communications. Things that need to happen very, very fast, but there may not be a whole lot of information associated with it. Next slide, please. So this is just an example of some Redis commands that were on the tryredis.io. So if you can step through here and see that it's almost like a terminal is one of the ways to communicate with Redis, and there are a couple of different commands like set and get. Set, you can just have a key and then a value, where you have set the key and then value, and then it returns that it set it. And if you do a get on that key, then you'll get its value back. There are a number of different other commands, such as increment, set, delete, and all of them are going to be atomic, which means they're going to happen instantly, or sorry, not instantly, but they either happen or they don't. Next slide, please. Elasticsearch is an example of semi-structured data. It's an advanced JSON document store. So what that means is you're storing JSON documents or data, and you don't need to set up all the JSON fields in advance. When you set it, then it can create a mapping which it extracts the information for each field from the JSON values. One of the awesome features about Elasticsearch is its advanced search capabilities. We'll get into that a little bit later, but what it should be, you should use it for is to store text documents where the fields could be potentially changing so that the mappings can be automatically updated or creating new mappings, and would require advanced search. Some examples of that would be a dating service that could handle age differences or geographic location, tastes, dislikes, etc. Or it could be a leaderboard system that depends on a couple of different variables. And another awesome thing about Elasticsearch is within their advanced search queries, you can do scoring, where you can either have a filter or a query. where a filter will be, yes, this document matches the thing you were querying, or a query where it assigns a score to each value, and it'll return things based on that score. Next slide, please. So here is an example of a couple of commands that you would send Elasticsearch. This is from a site that Joel Abrahamson had set up. And some of the curl commands, the first example is just a put command. You're putting a movie. You can see, if you look at the curl command, it's just going to the local host, so you have the Elasticsearch set up on your local machine. It's running at port 9200, and there's an index called movies, and the type is movie. And it's inserting that document at an ID of 1. So the document that you're inserting it for is The Godfather and all the information associated with that. And if you do a get on that ID, it returns back in JSON format. And you can see where it says the index of movie and all the other information associated with that one ID. Next slide, please. So here's an example of a simpler but also a example of the query system of Elasticsearch. Basically, you're looking for a query string of drama, but then you're also filtering the query based on the year of 1962. So first and foremost, it will only get movies that were made in 1962. And then from that, it will see which documents match the query string of drama and return you potentially a list or potentially no documents based on that query. Next slide, please. Titan is a bit different than Elasticsearch and Redis. Titan is a very robust and modular graph database. It's designed to be very easy to scale and just easy to use graph information. Its intended use is processing of graphs so large they require storage and computational capacities that a single machine can't provide. And another thing that makes Titan awesome is its plug-and-play nature. It more of acts as a wrapper on top of other databases, and depending upon which database you choose as the backend, it can fulfill all three different possibilities of the CAP theorem. And it just makes Titan an awesome product to work with. And like Hank said before, one of the ways that you would use it for could be LinkedIn connections, because you can see the different ways people can relate to others and the way people are connected to each other. Next slide. So I wanted to display an example of the graph data and how you might store it in Titan. I got this image from the Titan tutorial that's online. So it has nodes and edges, where there are different properties associated for each node. Like this is a graph of numerous different gods of the Greek mythology, where each node could have the name, the age, and each type of god that they are. And the edge can associate like Jupiter with Neptune, where they're brothers. One way to traverse graph data would be, or to get data out of a graph database, would be to say, give me all the brothers of node with the name Jupiter. So you would get back Pluto and Neptune, because both of them are listed with edges to Jupiter. Next slide. I think, Hank?
All right, so each of those technologies in itself is extremely interesting. But things get really, really interesting when you're able to combine them together into a single solution. Now, recall earlier we had used kind of an iceberg mentality there, where the analytic and the visualization is kind of on the front end. Now, what we've found is a lot of big data problems are very well suited for kind of optimizing your analytic for the questions that you're trying to ask. And so, depending on what you're trying to do, and even within an industry, you're going to be developing customized analytics and customized applications or algorithms to solve extremely specific problems. And so if you want to think of that, those are the things that users derive value from. Those are the things that, as I mentioned earlier, provide the insight and the knowledge for people to actually translate data into something that they can work with that makes their job better, job faster, more productive, and so forth. So, as we mentioned earlier, that's only the tip of the iceberg, but it's such a really, really important part of it. So when you look at an enterprise, one analogy we like to use is, if you can either build a whole bunch of icebergs and be saddled with building a humongous infrastructure for big data for each of your applications, or if you possibly can, let's try to reuse some of these patterns and provide the analytics and applications customized for what people are looking for, and then try to build some commonality into the iceberg that's below the water. So what's below the water, again, are these data stores. And so we talked about Redis, we touched briefly on Hadoop today, Titan, Mongo. The list goes on and on and on, and it'll continue to change forever and ever. But the more that you can actually get that iceberg under the water to be transparent to your front-end users, the more successful that your architecture will be, and you'll be able to react and accommodate the varying and rapidly changing needs from your users. So that's why we use the iceberg paradigm. And on the right-hand side, as you can see, what we're trying to do is transform the model from building a whole bunch of small icebergs from end to end for each of your applications, and try to build some commonality for the stuff under the water that the user doesn't see. And then allow developers and solution providers to really concentrate on providing the intelligence, information, and knowledge to users. So, if you go to the last slide, please. So what we've done here, and this is just to try to tie it all together, is provide a, Joe had mentioned earlier that he's working on EasyBake, and this is an open source package that tries to tie this all together. And so if you look on the right-hand side, what we're trying to do is provide a layer where you can plug in your custom applications, whether they're legacy applications or new applications, and then underneath of it, we provide, and again, to use the analogy, this is the iceberg below the waterline. Security layer, the execution layer, whether you're doing batch analytics, you're doing database queries, federated queries, streaming processing, so forth and so forth. And then at the very bottom, the physical databases, whether it's Redis, Hadoop, even traditional SQL databases like PostgreSQL or Titan for graph. So as you can see, this is just a very simple example and simple introduction to a variety of technologies that comes across a big data problem, and the various ways of attacking it, both from an individual technology perspective, but also from trying to tie it all together into an enterprise solution. At this point, that's the end of our briefing, formal briefing, so we'd like to open it up for any questions that the audience might have.
Okay, give us just 1 second to get everything ready here.
All right. We'll start off with, they wanted to go to more of a CSC piece and wanted to ask you guys around what is the culture like at 426 and CSC?
Great question. So 426 is a small business that was acquired by CSC a couple years ago, and our focus really is modern software engineering with big data technologies, mobility technologies, a lot of kind of modern monolithic stacks, like whether it's Grails, Rails, Mean, so forth and so forth. And so from that perspective, we try to maintain the same culture that industry has for these kind of technologies. So we don't wear the tie to work. We rarely do, if ever. I don't think I've ever seen Joe with a tie.
No. I have a couple, but maybe if I end up going over to the headquarters, maybe. But every once in a while, but not ever usually around here.
Right. So we try to keep it technology centric. We are very fond of agile software engineering, and from that perspective, agile is great if you've ever worked with it before, because it really puts the power of decision making into the software engineers. And the main premise that I like from agile is what you're doing. It's not really the old style command and control where the requirements and the tasks kind of flow from above. Really what you do with agile is you get a team of smart people together, and you put them in front of people who have the problem, and that's usually the customer. And what that means is the people who are in the best position with the knowledge to solve the problems, the people with the software development expertise and the ability to learn the technologies or experience with the technologies, are really the ones who are first exposed to the customer and can be the first ones to say, hey, you know what, this is how I would solve that problem, and they go off and do it. So what that means is the solution and the design and the task don't get diluted and they don't get lost. And it really puts the focus on the software engineers, and it gives them much more broad breadth and creativity, opportunity for creativity to apply to the solution.
Excellent. Okay, our next question is shifting back to big data. Where do you see the future of big data going, and how will companies decide to use it?
That's a great question. A lot of that's still yet to be written at this point. My view, and I'll let Joe speak in a second, but from a high-level perspective, I would say that we've jumped the gun on big data at this point. We're still learning quite a bit about what we can do and what our customers are learning, or what they can do with the technology and with the data that they have. And so what we're finding is, a lot of early steps. It's not like, here's a problem, can you please solve it with a traditional engineering solution. A lot of times, our clients don't quite understand what the problems they're trying to solve is. All they know is they have some problems that are looming that are going to require more muscle and more technology than they currently have to bear. And so I think we're currently in a very kind of discovery mode right now. And so there's still very much a lot of opportunity to kind of shape where this industry goes. Per the discussion we've just had, we've been focusing on trying to scout out and survey a lot of the new technologies that have popped up in the last couple of years and see where they're optimized for specific problem sets that our customers have. These things are popping up and getting traction and more traction all the time. So some good ones also that are kind of the next steps. Spark is getting a tremendous amount of attention as far as analytics go. But I think the book is still being written. So the dream of big data is I'm going to get prescriptive information from my data, and just shy of that, I want predictive information. But there's so much data in this world right now, and our customers are so overwhelmed with so much stuff. At this point, we're just trying to solve the descriptive problem half the time. So there's really a lot to be written here, and there's a lot of opportunity to shape the components that are being built, as well as reassemble them in different novel ways to solve these problems.
I see big data as it's information that we've just been able to leverage recently. I think of big data, one of the examples I think of is when you go to Amazon, you see it keeps track of each item you saw, which item you clicked between, the path that you went between items for. Traditionally, it was we know the users, which things they bought, and that's about it. We know their information. But now big data is enabling people to exposes all of that information and lets them get analytics based on all that information. So if you go to Amazon, and it'll provide you a list of, with this item, all of these other things were typically bought, or if people looked at this item, typically they looked at these other items. And where I see it going in the future is the Internet of Things, where everything is going to be just associated with the Internet. One example, the thermostat, the Nest, it's associated with it's something that typically wasn't associated with the Internet, but now you can just control it on your phone. It's going from what we have now to the Internet of Things will be a huge leap in the big data as well, and we'll probably see that over the next 5-10 years.
Now, from an execution perspective, I just leave one last note. This stuff is changing so fast, right? And so, we just went over, and Joe kind of glossed over some of the high-level details of these technologies. From a hiring perspective, it's interesting because, this stuff changes so fast that it's not really that important for candidates to be experts or really versed in these technologies. What's more important is that they have really strong fundamentals in object-oriented programming and the ability to pick up these technologies quickly. Because guess what? In 9 months, 18 months, these things might be obsolete, right? And so if you're an expert in Redis or you're an expert in Titan or something like that, it's really not understanding those APIs that's important. It's really understanding the fundamentals and being able to pick up the next big thing as well. So being kind of dynamic and prepared and equipped to handle any of these technologies and whatever's coming down the road is actually the more important thing. So in our interviewing process, we always look for strength and fundamentals. And so, if there's one takeaway from this discussion, it's focus on the fundamentals, because that's what's going to get you. Because everything else changes. I mean, technology, the exciting things that move so quickly, but the flip side of it is, you've got to be able to stay with the changes in order to stay current.
Excellent. And that was a follow-up question, was how do you manage in big data with Internet of Things? But I think you kind of answered that. Okay, so the next question is, what kind of growth are you seeing within the financial services sector?
That's a good question. I don't think that we're going to be able to answer that question too well, mostly because we're part of the government sector at this point. I think overall the commercial sector is seeing 20 to 25% growth at this point, and I think the financial sector is a major contributor to that. But from my perspective and Joe's perspective, we're mostly working with federal, state, and local government, and so when we talk financial, it's generally involved with agencies and organizations that have to do with finance, and it's a little less coupled with that too. How fast Wall Street or kind of those commercial firms are going.
Excellent. Next question is, can you guys hear me okay?
Yeah.
Yes.
Okay. Next question is, what's a more better option, Java or Python for building applications using MapReduce framework? I'm technical now.
Want to take a hack at that?
I'd say it really depends upon what else you're trying to do. Like what I was trying to get to in the presentation for the databases, there's a bunch of different ways to accomplish the same task, but typically there's a specific way that you should do it. And if it's easier for you to interface with Elasticsearch using Java, then you should use Java. But if it's easier to associate it with Python, then I'd suggest using Python. It really comes down to the underlying utilities that you're trying to use.
So I have a slightly different take. I agree with you very much so about, it depends on what you're trying to do. And it really depends on kind of the environment and the goal of the project, right? So a lot of what we do here from a enterprise perspective is very much productionalizing prototypes or models or so forth and so forth. And from that perspective, we're looking at Java as one technology, Ruby as another technology, and then JavaScript actually being part of the development stack is also very important. These are kind of our main bread and butter tools of the trade these days to making things happen. And again, it really depends on the sector you're in, but we're talking mission critical user-facing applications for whether it's analysts or business people or decision makers and so forth. So obviously it changes a little bit if you talk about back end or whatnot. Python's awesome. I mean, it's really great. And I know, Joe, you feel very positive about it.
Yeah.
It's rapid. You can iterate so quickly and prototype stuff very quickly. And a lot of the MapReduce APIs are very much very integrated, well integrated with Python, so you can spit out stuff very quickly. The challenge is, if you're working in an enterprise kind of environment, Python tends to be a little less easy to maintain for a long term in the system. But whereas if you are working with a data user trying to kind of push the envelope on exploring where analytics are going, it happens to be a very good kind of fast prototyping, fast fail, fast success medium, so that you can kind of iterate really quickly. So what we've found in the past is we've teamed up with maybe data scientists or researchers who choose Python as their weapon of choice, and they build out the deep models that have to do with the subject matter domain expertise that they're engaged with, and we'll take those Python algorithms and either port them or instantiate them in kind of a larger system so that the benefit of their expertise can really scale up to all your other users, right? Because generally what happens is the best insights come from your star analysts, the people who know the data really, really, really deeply. And these guys aren't necessarily your best programmers. In some cases they are. But what you want to do is scale it out. So you don't necessarily want to have your enterprise or your business process limited by one star analyst. What you want to be able to do is take that insight and analytic and be able to scale it out so your team of 10, 20, 30, or even more can take advantage of their knowledge. And so it really depends, like Joe said, what you're trying to build to. There's a right tool for the right job, similar to the database side, but there's definitely a place for both. But from an enterprise perspective, I would choose, again, our choices have tended towards Java, .NET sometimes, as well as Ruby and JavaScript.
Mm-hmm.
Okay. Next question is, how important will big server farms techs be? I think I messed that up. How important will big server farms be in the future for big data? Server farm techs?
Is it server farms or server farm like administrators?
Techs. T-C-H. Yeah, like technicians.
We'll hit both real quick, I guess. I mean, the first one, how important will big data server farms be in the future? I hope that they'll be so important that I won't have to worry about it, right? And that's the beauty of Amazon. And whereas even just 3 years ago, we're building our own big data, servers and racks. Mm-hmm. Nowadays, it's just too easy to go to Amazon and purchase it, right? So as they get more and more important, I don't want to worry about it at all. So hopefully, it becomes so good and so mature that it's just completely out of my vision.
Yeah, it was so cool. I went to a Hadoop World last year and was in a talk, and it was a tutorial on data science. And a guy had rented a bunch of Amazon boxes so that everybody could SSH and then execute things. He just rented them for an hour so everybody had servers to work with. It was actually a really cool event.
As far as techs go, I would say this. I'm not really familiar with what happens inside those data centers. I'm sure someone's got to keep the lights on, and for those to be profitable, I'm sure they've got to drive that down to as few people as possible, looking for blinky lights and so forth. But I would say from a system administration perspective, there's definitely a transformation in this industry. So whereas 10, 15, 20 years ago, the big deal was, where's my Unix SA? Where's my Unix SA? Where are my network engineers? It's really transforming, right? And everyone's kind of crawling up the food chain, the value chain, as far as what they need to get done. So today, if you look at some of the technologies that Joe and I talked about, they're getting more and more myriad, and they're getting more and more complex, and each of them have specific things that need to get done in order to install them and maintain them and tune them and so forth. And so as software engineers, from an application development perspective, get more and more focused on kind of the end analytic and serving things up to the user, someone at the same time really has to be focused on ensuring that platform, that big data platform, is viable, healthy, tuned, and so forth for the software application engineer to use. And so, in recent history, that really hasn't been the case. Your software engineer kind of installs a package, or maybe you have an integration engineer or something like that, depending on how big your development team or your engineering team is. But at this point, we're finding that there's definitely a development operations or DevOps aspect to it. So we're looking for system administrators to start taking on additional pseudo programming skills, such as scripting, whether it's traditional C shell, Bash, so forth and so forth, or Puppet Chef for orchestrating kind of installations across multiple nodes and so forth and so forth. So yeah, it's going to be important. It's going to evolve. As this technology gets more mature and gets more exciting and gets even bigger and bigger, it's really going to make the job much more interesting up and down the entire stack. So software engineers are going to be exposed to much more interesting technologies and fun things to do. And similarly, sysads are going to be, looking at more, application platforms for them to install, tune, deinstall, upgrade, and so forth and so forth. And overall, you're just going to see the whole kind of state of technology that's continue to grow and evolve.
Excellent. So how do you see smart data?
Smart data. I'm not familiar with that term.
Okay. You want me to move to another question?
It
just said.
I'll just say something real quickly. I think if you're talking about like metadata around data, yeah, I'm not sure.
It's just the question. I don't know. It's not clear enough. Let's just go to the next one. It says, and this is the same person. So if you could just clarify your question. So here's the next one. How do you see BAs using big data for providing solutions? Do they need to be, quote unquote, big data savvy?
Oh, BAs as in bachelors?
Yeah. Let's say okay. How do you see BAs using big data for providing solutions? So probably business analyst.
Oh, business analysts.
Okay.
Great.
Yeah. How do you see them providing that as a solution? And do they need to be big data savvy?
It definitely wouldn't hurt to be big data savvy, just to know where the climate of the industry is going and knowing what is possible with the technologies of nowadays.
So how in depth does a business analyst really need to understand big data? I think that's the question.
I think there's a continuum or spectrum there, and I think if you've got the technical savvy as a BA, as a business analyst, to go deep, then do it. There's going to, I mentioned earlier, this is definitely an area of technology that's still maturing at this point, and there's a long ways to go here. So it's going to be a very exciting time, over the next several years. And so if you have the technical savvy to kind of get smart about this stuff, I definitely encourage you to go deep and go hard, right? So I think fundamentally, as a business analyst, there's a couple ways you can go. I think ultimately, you're valuable because you understand the business process, right? Mm-hmm. So step one, make sure you understand the domain, right? I think that's super important. I would even argue if you're a software engineer, it's important to understand the domain, right? So, So I mean, if you're supporting the financial sector, it's good to know, how balance sheets and income statements and all that kind of stuff kind of fits together. If you're supporting a space program, it's good to know, a little bit of how stuff works as far as communications go, how wireless goes, how orbital dynamics goes. It's good to get a little dangerous kind of in the field that you're working in, because especially if you look at like agile software engineering, the more kind of background you bring to the table, the better resolution, better fidelity your solutions will be. So, but getting back to the business analyst. So as I said, number one is understand your domain. But number two, I think there's some fundamental data analysis skills, whether you call it big data or not, that would be important to know. So fundamentally, statistics is huge, right? So if you understand how to read data and how to handle variances and standard deviations and probability and regression, I think that's a great start to figuring out, to kind of getting your hands dirty with kind of the technical aspects of big data. Big data is, I hate to trivialize it, but it's just another tool set there, right? And so, in some cases, it really depends on what you're trying to look at. You may want to use ordinary statistics, or you may want to apply big data techniques. It's really the right tool for the right job. And it doesn't hurt to have breadth and depth with these kind of hard quantitative skills in order to succeed.
Good. Okay, a couple more for you guys. So this one's a little lengthy, but they asked, Do you think someday we could use big data analytics in the future to replace the way companies get feedback from their customers? An example is surveys, feedback, questionnaires.
I would say that it wouldn't replace it. I would say that it would better extract information out of it. You would, if you have a whole bunch, large company getting information or feedback from many different users, it sometimes can be hard to figure out what the core issue might be. You could have people complaining about multiple different parts of your website, but then when you come back and maybe look at the logs or try to extract data out of it, you might see there's one server that keeps getting really slow over and over again and causing negative experience for these users.
Yeah, I think it's always important not to lose sight of the process. So technology is going to be more and more important than ever, and we're going to take advantage and exploit it every way we can. But I think the process, as you pointed out, is more important.
Mm-hmm.
As far as using big data tools and kind of tools from technologies kind of adjacent to it to kind of augment it, I think there's great opportunity to do that. I mean, if you get thousands of comments, things start to get untenable. If you get millions of comments,
mm-hmm.
Who's gonna have time to read through all those, right? So if you have the ability to use entity extraction and entity disambiguation to kind of pull out keywords from these comments to kind of see what's going on. You can look at sentiment analysis. So there's a couple algorithms out there that can do that. If you look at, for example, Stanford NLP, they've got a sentiment analysis, open source sentiment analysis algorithm that you can download. It's machine learning, so you can kind of it's already pre-trained on like I think it's a movie database. But you can continue to train it on the specific data that you happen to have to kind of get it more and more accurate. So definitely, I think there's definitely a lot of ways to kind of take advantage of the technology to help solve these problems.
Good, okay. And can you give an example of industry use of the Redis DB?
Say that a question again?
Sure, it says, can you give an example of an industry use of Redis DB? So I'm guessing that's databases.
Yes.
So
can you talk about what we do with Redis?
Not entirely sure.
Just from a customer privacy perspective.
Yeah. So there's a bunch of different ways that you could potentially use Redis. It mainly comes down to, like I said before, where you need things to be very fast and very available.
I'll use a good example.
Okay.
And this is, I'm extrapolating this a little bit, so kind of,
mm-hmm.
hiding the guilty, hiding the innocent, protecting the innocent, right? So, if you could put like a phone book
mm-hmm.
in Redis, whereas, in your email you might see, someone's name, right, in your inbox, in the text of your body of your email. You could have a directory of people's names and their email addresses. And so Redis would be a really good way to index on the person's name and give you a little popover that tells you what their phone number is or any other vital statistics. So anytime you need a real fast response on just like a key value pair lookup, Redis can come into play.
So I think I thought of a way to abstract kind of what we do. So you could have multiple different technologies trying to use similar information, like a large platform that references a small subset of data many different times. If you set up Redis, you could quickly hit those and get those individual key values quickly and atomically throughout the whole system.
Okay, good. And someone asked, they're in college, really interested in big data. Not all colleges offer a ton of classes in it, but any suggestions on how to market themselves for a job in big data upon graduation?
So I've found, to market yourself, there's many different tutorials that you can take online. And then one of the main things you should do is try just programming it. Go out and get a GitLab or GitHub account, like fork some projects, try and make something of your own, and try to make something out of it, and then on your resume actually list what you did as well as your GitHub account, so that the potential employers could go and check out and be like, oh man, this guy's really awesome, he implemented this technology in a really cool way, just to try and show that you are going the extra mile. And I'm one of the people that recruits for 426 or does interviews for 426, and it's definitely awesome to see when someone has gone out and done their own projects on the side and that they can talk about the big data stuff. And to slightly parallel that, coming out of college, I had very little, or I didn't learn any big data stuff in college. But the main skill that I learned was how I learn. It's how to pick up new skills and recognizing the best way for me to learn. I learned very well by just doing things. I didn't learn well by professors just lecturing at me or sitting in lecture halls. I learned by staying up till 6 a.m. trying to program something and just hammering away at it and trying to look up things online and try and apply it quickly to what I was doing. And that's definitely how I learn on the workplace now. I've learned multiple different languages, bunch of different technologies by applying the knowledge that I learned in college on how to actually learn.
Joe, you're spot on. I just want to reemphasize though, it doesn't help unless you've demonstrated you're a solid fundamentals programmer.
Yes.
So that's really key. So I mean, if it doesn't matter, what you've done from a big data, MapReduce, I did this, I did that.
Mm-hmm.
If you can't answer kind of like simple object-oriented questions, it's not going to fly. So just make sure you concentrate on fundamentals, and then I think everything you said was great.
Mm-hmm.
GitHub is awesome,
Yeah.
right? So it's the equivalent of an artist having a portfolio.
Mm-hmm.
In 2015, the equivalent of that for that software developers is, hey, here's my GitHub account, and this is all the cool things I've worked on. And people can check it out. You can see what you've done exactly and what you've contributed to, and it gives you a very real sense of what you really can do. So.
Definitely.
So Joe is a rock star. I love it. All right. So our participant, they did clarify the SMART question, and basically he's asking for the future, what are some of the things that, from your experience, that we could be thinking about using big data? Like, what's some of the smart things that we should be thinking about in the future?
Well, for one, like I mentioned before, the Internet of Things, just where everything is just attached to the Internet, and you can extrapolate or extract value out of the data from that. And I think a lot of different things we just haven't seen yet. Like 5-10 years ago, no one would have thought that Amazon would have implemented all the different ways of getting data from click streams and what people have been viewing. But now it's just very common. I think in the next 5-10 years, there's going to be some awesome new innovations.
Yeah, and a lot of that is going to be focused on the nature of this data. Mm-hmm. So if they're able to combine different types of data streams together in new, novel ways, that's really going to kind of create new applications.
Excellent. Okay, so you guys have covered some of the privacy stuff. We had a question around that. We had a question around storing secure information such as government records and medical records and ensuring that it is safe. Is that something that you can comment on?
Yes.
In what?
I'll just cover it real quickly.
Yeah, if you want.
So you just want to make sure that you have some kind of row-level security involved, and there's a couple ways to skin that cat. So one implementation of Hadoop, for example, is called a cumulo. That gives you row-level visibility. But there's different ways to solve that problem, not limited to just cumulo. At the end of the day, you just want to make sure that each individual piece of data is protected and there's some kind of mechanism that says who can see this, who can't see this.
Mm-hmm.
And what's interesting is it goes beyond just normal like user queries like you would see 5 years ago, 10 years ago out of like a SQL database. Nowadays you have to worry also about analytics that run in the background that might comb through all these databases. You have to worry about, does this data by itself combined with this data by itself, does that create a piece of information that might be now restricted because they got put together? And so those are the things that you want to make sure you have the mechanisms for. And like I said, Accumulo is one distribution that gives you that ability, but it certainly isn't the only one out there that does. And so I think the book is still to be written on how best to do this, and there's still a lot of ways to do it. But at a very kind of high level, that's kind of the method you have to take.
Mm-hmm. And our last question, because we're going to narrow it down to the last question. Is big data, and I'm trying to just paraphrase it here, is big data here to stay, or is it temporarily here to phase out into something else?
So I definitely think it's here to stay, and I almost see it as the next step and more of a phrase for expanded analytics. It's more of going from traditional databases where you could say, okay, give me a list of all these users, to like I keep going back to the Amazon example, but trying to get information out of large sets of data, like the click streams that are coming through. It's expanding the analytics, and it's more of just a threshold where if you're no longer if your data needs have exceeded traditional SQL databases, then now you're in the realm of big data. And as we're able to store more and more data, that threshold may get higher and higher. So the threshold for big data and the analytics and the databases that you use and associated with that are going to be in the higher volume range.
I agree. I mean, it's here to stay. It may not be the buzzword that it is today, and hopefully it doesn't. I mean, hopefully it becomes just in the fabric of technology. But I think there's no stopping the accumulation of data at this point, and so it's just getting bigger and greater volume, greater variety, and just different ways that people want to extract again information and insight out of it. Right. So the data itself is really not that important. It's what insight and knowledge you can derive from it. So I think there will always be that thirst for knowledge and information as people want to know more about kind of what's going on and how to make themselves better, faster, cheaper, more efficient, effective, and so forth. You just may not see the emphasis on big data as a buzzword or a field,
Mm-hmm.
but it's here to stay as far as a piece of technology. And I mean, it could be overshadowed for all we know,
Mm-hmm.
but it's here to stay as a part of the fabric.
I think it could just eventually just be part of the regular analytics, where it's not even known by the buzzword big data anymore.
It's just
But it's just what we do. It's just it's just analytics.
Mm-hmm. And I think that's what is important when you said earlier about having a core foundation of skills, because if that terminology isn't there, it doesn't necessarily typically need to be there, because you can transition into the type of work that it is and not necessarily by a title.
That's right.
Yes.
Yeah. All right. You hung in there, Hank. That's excellent. All right, Amanda, you want to close us out?
Absolutely. Well, I just wanted to thank both of our speakers and let everybody in the audience know this will be on our YouTube page, so you can watch it again if you need some highlights and things like that. So thank you all for coming. Thank you, Hank and Joe. We really appreciate your insight, and we learned a lot. I know I personally did. So thank you all very much. I'll put a screen up at the end just if you want to learn more, where you can turn your attention to. Have a great rest of your day. Thank you very much for listening.
Thanks.
All right. Bye.